End of the chapter. We have the last question. Question number 4. Two products A and B. Their current market shares are 50% and 50%. Each week, the switching takes place of those who bought A the previous week. 60% buy it again, whereas 40% switch over to B. And of those who bought B the previous week, 80% buy it again, whereas 20% switch over to A. Find their shares after 1 week and after 2 weeks. If the price war continues, when is the equilibrium reached? There are 3 information given. The present market shares are 50%, 50%. Through that we can define AB, the distribution AB equal to 50% and 50%. Now we are moving to the answer. Similar to the previous problem, that is very easy. Directly we can write the distribution function AB. The product A and B has 50%, 50% present position. So at present they have AB equal to 50%, 50%. That is equal to AB equal to 0.5, 0.5. Then there is a switching every week. The first transformation is, that is a transformation. Okay. Now that is a transition. The first transition happened. Who bought A the previous week, 60% buy it again. So 60% buys again A and 40% switch over to B. So the transition probability matrix is T equal to, the transition probability matrix T equal to AB, and here also AB. In A, again buying 60% of the people, so 0.6. Now from A to B, that is switching from A to B, is 40% given, so 40% means 0.4. And then of those who bought B the previous week, so start from B, 80% buy it again, so this is 0.8. Then switching from B to A, whereas 20% switch over to A, that means the B to A switch over 0.2, 20%. This is the required transition probability matrix. We should find 3 cases here. We find shares after 1 week and after 2 weeks, and the price war continues the same way it proceeds. When is the equilibrium reached? That is also question. Now we should find shares after 1 week first, then shares after 2 weeks, then at the equilibrium. When is the equilibrium reached, we should find. For that case, now for first case, shares after a week. To find shares after a week, multiply the distribution function AB 0.5, 0.5 with the transition probability matrix 0.6, 0.4, 0.2, 0.8. That is equal to 0.5 into 0.6, 0.03, and then 0.5 multiplying 0.5, 0.6 and 0.2. These two yields 0.30 and 0.10, and 0.5 to 0.4, 0.20, 0.5 to 0.8, 0.40. Adding these results 0.40 and 0.60. So the SAS after a week, for A it is 0.40, B 0.60 in percentages. SAS after 1 week, A follows 40% SAS and B follows 60% SAS. So the first subdivision is completed. The SAS after 1 week is calculated here. Now we are moving to calculate the SAS after 2 weeks. To calculate the SAS after 2 weeks, now take the distribution AB as 0.40 and 0.60 and multiply this with the transition probability matrix. So SAS after 2 weeks, SAS after 2 weeks. Now after a week, 0.40 points, this is the current SAS position now for A and B. So take this one 0.40 and 0.60 and then multiply the transition 0.6, 0.4, 0.2, 0.8, which is equal to, again multiplying these two, 0.4 into 0.6, 0.24 plus 0.6 into 0.2, 0.12, 0.4 into 0.4, 0.16, then 0.6 into 0.8, 0.48, which will be equal to 0.36 and 0.64. So the SAS after 2 weeks, how to calculate it? Take the SAS after 1 week, 0.40, 0.60 for A and B, and then multiply. The same transition is happen. So multiply this answer, this transition probability matrix with the 0.4 and 0.6. It will be equal to 0.36, 0.64. So after 2 weeks, the transition happen in this way. The final final answer is 0.36, 0.64. That means after 2 weeks, the market SAS for A is 36%. For A equal to 36% and for B it is equal to 64%. Now, so gradually the B SAS is increasing here. And if the same way, if it continues, the price war continues, when is the equilibrium reached? That is the third subdivision. At the equilibrium, we must have probability distribution function into transition probability matrix will be equal to the same distribution value. Here, AB into transition probability equal to AB. AB is unknown when at the equilibrium, but transition is known by us. The transition probability matrix T equal to 0.6, 0.4 and another case 0.2, 0.8. Second law. Now multiply this 0.6, 0.4, 0.2, 0.8, that will be equal to AB. Now multiply this, we can have 0.6A plus 0.2B and 0.4A plus 0.8B equal to AB. Now these are equal matrices. The equating corresponding elements we have 0.6A plus 0.2B equal to A, and we have another equation 0.4A plus 0.8B equal to B, where A plus B here, when the condition satisfies sum of A and B equal to 1, which implies B equal to 1 minus A. This is very important condition because all the entities are probabilities and sum of the probabilities of all the events should be equal to 1. In that case, it is taken. Right. Now, I am taking only the first equation, 0.6A plus 0.2B equal to A. Now, substituting B as 1 minus A in this, we can have 0.6 A plus 0.2 into instead B substitute 1 minus A, 1 minus A, that is equal to A. This is transition probability matrix. Okay. Now multiply 0.2. 0.6A plus 0.2 minus 0.2A equal to A. Adding these two results, 0.6A minus 0.2A, 0.4A plus 0.2 equal to A. Now 0.2 equal to A minus 0.4A. A means 1A, this is 0.4A. Subtracting, we have 0.2 equal to 0.6A. 0.2 equal to 0.6A. Here A equal to 0.2 divided by 0.6, that is equal to 1 by 3. That is equal to 1 by 3 means 0.333 approximately. You can take 0.33 and A equal to 0.33. Therefore, B equal to 1 minus A, 1 minus 0.33, that is equal to, therefore B equal to 0.67. Therefore, when the equilibrium reached, when A and B are, A is 33%, A has 33% of shares and B has 67% of shares, at the time the equilibrium will be reached. Therefore, when A equal to 33% and B equal to 67%, the equilibrium reached. Therefore, the equilibrium reached when A equal to, equilibrium reached when A equal to 33% of the shares and B equal to 67% of the shares. That's all. Completed all the problems in the last exercise also. We have completed 3 exercises. Now we are moving to the 4th exercise, that is 1 marks. I have written first 6 questions here, and if A equal, first one, if A equal to 1, 2, 3, matrix 1, 2, 3, then the rank of A transpose is dash. The given options are, some of the options are given. Now how to find the rank of A transpose? A is given 1, 2, 3 and it implies A transpose is equal to 1, 2, 3. Multiplying A into A transpose, A transpose is equal to 1, 2, 3 into 1, 2, 3. It's order 1 cross 3. It's order 3 cross 1. So both are multiplicable. Then when we multiply, the order will be equal to 1 cross 1. Order of the matrix is equal to 1 cross 1. So multiply it now. Row by column multiplication, which will be equal to 1 into 1, 1, 2 into 2, 4, 3 into 3, 9. That is equal to 9, 10, 14. Okay, the order is 1 cross 1. What is the rank? We have 1 cross 1 matrix. The maximum minor value is 1 cross 1. In that matrix, the entry is non-zero. That means its R is, its rank is 1. Therefore, rank of this A transpose is equal to 1 because we have 1 cross 1 minor. The maximum minor value is 1 cross 1. So, its determined value 14, non-zero. Therefore, its rank is rank of A transpose equal to 1. For second one, the rank of M cross N matrix whose elements are unity. The rank of M cross N matrix whose elements are unity. That means it is a M cross N matrix. That means some number of rows and some number of columns are there. For example, if we take one M cross N matrix, all the elements are unity. M cross N, I am taking 3 cross 2, or you can take 2 cross 3. Anyway, you can take. Whose elements are 1, unity. Whose elements are unity. That means all the elements are 1 in it. Now 3 cross 2 means 3 rows and 2 columns. 1 row, second row, third row. 3 rows and 2 columns. Here 2 cross 3, 2 rows, 3 columns. But all the entries are 1 in it. If you take any M cross N matrix, who all the entries are 1, then what will be the rank? Now, all are identical. They are all identical rows. So, we can subtract R which implies equivalent to applying elementary transformation here. All are identical. I told you that, okay, listen here. Now, R3 tends to R3 minus R1. So, all the entries are 0, 0. R2 tends to R2 minus R1 again 0, 0. That is 1, 1. If all the entries are equal, only one row, it may be any order, only one row, first row only remains. So, all the entries are 0. So, there are 0 row, the only one non-zero row will have. That means the rank of A is 1. The rank of M cross N matrix whose elements are unity is of order 1, is of rank 1, whose rank is 1. It may have m number of rows and n number of columns, you need not worry about it. All the entries are 1 means only one row will left out. So, we can easily write the rank of A equal to 1. Then, question number 3. So, in this for the second one, rank of A is equal to rank of that M cross N matrix is equal to 1. Third question. The given transition probability matrix 0.4, 0.6, 0.2, 0.8 at equilibrium A is equal to dash. So, at equilibrium we have AB into transition matrix is equal to AB. That is 0.4, 0.6, 0.2, 0.8 into AB equal to AB. Forming the first equation, 0.4A plus 0.2B equal to A. We are familiar in that 0.4A, 0.2B, 0.2B equal to the first element equal to A. Now, where A plus B equal to 1 here, B equal to 1 minus A, substitute in it, 1 implies 0.4A plus 0.2 instead B we have 1 minus A, that is equal to A. Now 0.4A plus 0.2 minus 0.2A equal to A. Here simplifying these two, 0.2A plus 0.2 equal to A. Now grouping A one side and constant other side, 0.2 equal to A minus 0.2A. that is equal to 1a minus 0.2a, 0.8a equal to 0.2. Therefore, which implies a equal to 0.2 divided by 0.8. Cancelling, we have 1 by 4, that is equal to 0.25, so or 1 by 4. You can write it as in the option given as 1 by 4, so a equal to 1 by 4. A follows 1 by 4. Fourth question, a equal to 2008 is given. Then rank of a equal to dash. Now 2 by 2 determinant. The maximum order is 2 by 2. The 2 by 2 determinant is 16 minus 0 equal to 16, not equal to 0. Therefore, 2 by 2 minor non-zero. 2 by 2 minor non-zero. Therefore, rank of A is equal to 2. Because in determinant method, the rank is decided by the maximum order non-vanishing minor. That is, the maximum order non-vanishing minor is taken as rank. Therefore, here 2 by 2 minor non-zero. Therefore, rank of A is equal to 2. And for fifth question, the rank of a matrix 1, 1, 1, 1, 2, 3, 1, 4, 9. Let it be A equal to 1, 1, 1, 1, 2, 3, 1, 4, 9. You can form you can find a determinant, or you can go to elementary transformation method. Now I am applying elementary transformation here. R3 tends to R3 minus R1. Because we have both entries are 1, easily we can make it 0, 0. Then 4 minus 1, 3. 9 minus 1, 8. Then R2 tends to R2 minus R1. Here also 1 minus 1, 0. 2 minus 1, 1. 3 minus 1, 2. No change in the first row. Then again, we are moving to make this 3 as 0. So 0 minus, for that R3 tends to R3 minus R2. Taking these two rows. 0 minus 0, 0. 3 minus 1, 2. 8 minus 2, 6. Then if we make this elementary 0, this one will become non-zero. So leave the process, stop the process here. So this is in equivalent now here 0, 2, 6, right. Now multiply. Sorry, here we can conclude in a different way. That is equivalent to. Here 0, we have 3 here. So multiply this by 3, then subtract. That will be easy to you to make that entry as 0. R3 tends to R3 minus 3R2. R3 tends to R3 minus 3R2. So 0, 3, 8. Then multiply R2 by 3, 0, 3, 6. While subtracting, we have 0, 0, 2. So here we have 0, 0, 2. And then if we make this 1 as 0, it will become non-zero. So stop the process here. 0, 1, 2, 1, 1, 1. Here we have 3 non-zero rows. 1, 2, 3. All are non-zero rows. Therefore, the rank of A is equal to 3. Or you can go by determinant method. Find the determinant value. Its rank is 3 now. So the determinant value will be not equal to 0. Directly we can write 3 by 3 minor value is non-zero. The rank of A equal to 3. You can choose like that way. The next question is sixth one. The rank of the unit matrix of order n. Already we have discussed while taking the classes in between the first exercise. The rank of unit matrix of order n is dash. We can take a 2 by 2 unit matrix. 1, 0, 0, 1. It's a determinant value. This is I2. It's a determinant value. Determinant of I2 equal to 1, 0, 0, 1, that is equal to 1, because it is a diagonal matrix. For diagonal matrix, determinant value, to find the determinant value, cross multiply the diagonal, that is enough. So multiplying 1 into 1, 1. And I3, for order I3, 1, 0, 0, 0, 1, 0, 0, 0, 1. For that also, determinant of I3 is equal to, it is a diagonal matrix, multiply the diagonal elements only, the answer will be 1 into 1 into 1 equal to 1. Therefore, here also we have non-zero entry, though determinant is non-zero for I2, determinant is non-zero for I3. If we take any order, the determinant value for unit matrix will be equal to 1, that is non-zero. So, we can easily conclude that the order is 2 by 2, the rank is 2. The order of unit matrix of order 2 is rank 2. The rank of unit matrix of order 2 is 2. The rank of unit matrix of order 3 is 3. Here is non-zero. Its order rank is 3. So if we take any order, that will be the rank. 2 by 2 is taken, the rank of A is 2, and 3 by 3 is taken, the rank of A is 3. Therefore, the rank of unit matrix of order n, if the nth order is chosen, its rank is n. Therefore, rank of unit matrix of order, it should be a unit matrix. For other matrix, we cannot say like this. Only for unit matrix, its order will be its rank. So that is question number 6. We have completed first 6 questions. Now we are moving to next 6 questions.